So I guess, what I thought in the first session, what I did is that I dived deep into perhaps the most important topic of retail analytics, that is the assortment optimization. And then I thought that it's very important to give a complete overview that what are the different or multiple dimensions of retail analytics. Though, see, there are two approaches of handling it. That one is that taking all the silos, all or not the silos, but taking all the compartments. But the other way is that giving a complete overview of, okay, these are the 10 things, 12 things one must be cognizant of if you're approaching the subject of retail analytics. And then ideally after that, each of these 10, 12 topics can be taken separately. So today's session is a kind of a holistic overview of what are the different dimensions, different aspects, different parameters one must be cognizant of, one must employ while approaching retail analytics. That's the whole perspective of today's session. Number one. Number two is that after covering the key pillars of retail analytics, I shall also discuss today that how do the different sectors within retail sector employ or adopt and apply retail analytics. Say, how do the apparel sectors apply it? How do the grocery or the pharmaceutical sectors apply it? How do the hardline retailers apply it? So that's the second point of discussion today. And the last point of discussion is about that was something, the question that Professor Dasgupta asked me in the last session is about how do you think that the business changes with the COVID? I believe that's something very important for any subject we learn today. Any subject, any body of knowledge, whether we teach or whether we learn, that's something very important. And that's very important for retail as well, because the consumer behavior shifted dramatically, and then the analytics should also adapt. Analytics should adapt to that change. So from that perspective, my third point of discussion is about how retail analytics shifted with COVID-19, how we have evolved, how we have changed to combat the challenges. So these are the three dimensions or three aspects I'm going to discuss today. I hope that's clear, right?
Yes, sir.
Perfect. Perfect. So let's start with the three key pillars of retail analytics. So very, very important is number one, the merchandise planning. I'm sure you are studying, for that matter, any of the retail analytics courses, which are there are n number of courses which are retail analytics or retail management for that matter, not only analytics. Retail management courses which spans for a year or 2 years. Merchandise management becomes a very, very important aspect, and even in the retail operations in the reality. So merchandise management, category management, uh, assortment management. These are all the key pillars that determine that what should be in the store, and of course, that is directly proportionate or directly related with the revenue that the store is generating. So merchandise planning and price optimization is, of course, I shall dive deep further, but having the right product or the right merchandise to the store, and not only having the right thing to the right place, but also at the right point of time. That's very, very critical. And the right point of time to the right customer. So all these things have to be right. Then only the magic, or then only the right revenue can be accrued. So that's the first part of merchandise planning and price optimization. Then comes a very critical aspect, which is true for, I guess, any business, even beyond retail. Uh, it's true, but even retail, it is further true, because ultimately you are the very essence, the very underlying philosophy of retail is giving a service. Retail is giving a service so that you are giving again the same thing, the exact product that the customer wants, uh, and when he or she wants it. And that's only possible when you know your customers right. So that's about the customer insight. And believe me, nowadays it is not about just segmentation. That means what we used to do some 10 years back, 20 years back. Okay, my segment has got my entire population of customers have got 5 segments, and then determining the 5 segments, and the thing is over. But that's not that's not what happens in this world, and it's not possible to happen for the simple reason is that the customers are so unique in the sense that every segment has got so many micro segments within it. So uncovering the subtle nuances of every micro segment, understanding them as much as possible to the extent of taking it to the mass customization. Many of the retailers do it for quite a long time. You must have realized. I'm sure you know about that. The two extremes of a continuum. One is about the mass marketing, and the second one is the other extreme, I would say, not the second one. Second one is customization, and then there is mass customization. Many of the retailers are doing it, the mass customization, and that's that's where AI actually plays a critical role. Which, of course, AI part I have taken it for tomorrow. Tomorrow, I'm primarily going to discuss the different technologies which are kind of part of the ecosystem. I always emphasize on this word ecosystem, because analytics don't work in isolation, right? It's very important to understand the ecosystem and how that entire ecosystem works. So AI is a very critical piece of the puzzle, and it's important for us to learn that how that helps in creating or rather in customizing the service for every individual. So yeah, uh, I'm sure you know about a few things, which of course I shall go into discuss in detail if time permits tomorrow. That many of the retailers customize it to the extent that what I'm going to see, what I'm going to experience, will be very different from how you are going to see and how you are going to experience the same website, same web page. This kind of stuff are it is nothing called one size fits all. So that's the kind of role. That's the kind of the highest degree of customer insight. What we are discussing now is possible by AI. And the third piece or the third pillar is the supply and demand planning. As I discussed in my last class also, the mother of all analytics in the retail is the right demand forecasting. And that is for the individual store level. And I shall discuss today that it is not about it is not only about rather it is not on it is not that not about it is not only about forecasting the right amount of product, but also every SKU of the product. Say, for instance, it happens many a time you visit a retail store. You might have got say apparel, for instance. You might have got the jacket or the blazer that you were looking for, but the size that you were looking for is not available. Yeah. So that's the kind of revenue loss for the retailer. So to avoid such kind of loss, we plan, we forecast to the extent of size, which I'm going to discuss. The first thing that we are going to discuss is the merchandise planning and price optimization. So any question, feel free to ask me, feel free to stop me, and feel free to discuss it. It's not about, I shall go slide by slide. That's very boring, I'm sure, for both of us, right? For both you guys and me. So feel free to unmute yourself. If there is no background noise, feel free to stop me, participate in discussion. Let that be a kind of interaction. Yeah, that's what we'll enjoy all. So the first thing within the merchandise planning and price optimization is what I discussed in the last class is all about customer-centric assortment planning automation. Each and every word is important, that customer-centric. Now, as I said, that these three pillars are kind of interrelated. Without the right demand forecasting, you cannot have the right product. Without the right customer insight, you cannot have the right demand. Without all these two, you cannot have the merchandise planning. You don't know what particular product is required and at what particular price point would that product be sold. So predict customer demand by channel and forecast the impact on future sales. So very important is to while you are predicting, of course, at the end you will sum up, but it's very important to understand that what kind of demand each of these channels are generating for you. Each of the channels means any retailer in today's world can't just depend on one channel, right? Uh, if you take the digital channel, it has got multiple variants. Each of the way Facebook is generating the customer, the way YouTube is generating the customer, the way Google is generating the customers are very different from all the different print medias or even the TV media. And within TV media, it is not only just the advertisements, you can have even the direct shopping experience through TV. So each of these are different channels. So a retailer should ideally have complete clarity about what is the number of customer each of my channel is generating. And of course, that is the data collection part, the first step. And once you have the data, then all this data fits into your model. And primarily, it goes to that same thing what I discussed in the last class is about the marketing mix model. So sales is dependent on several types of advertisements, several types of distribution strategies, and what's the exact impact of each of these channels we try to figure out marketing mix modeling. Then the use predictive and prescriptive analytics and advanced clustering to understand the customer's path to purchase. In a very important part. I wish I could take a separate class on the customer's path to purchase, what we call technically customer journey mapping. That's a very important part. So typically it happens, it's not that customer follows one path to purchase. In the sense that, say for instance, I have watched an ad on TV. Then maybe after a couple of days, I looked that on the website. I searched for that product on the website. Again, a few days might have passed. Retailer understood that yes, this is the same guy. Then the retailer popped up a few ads on my social media. Then I clicked, I landed up on the website, and then the purchase takes place. So that's the kind of interesting path to purchase. Ideally, which of course happens, not that this ideal and reality are very different. Uh, Retailer has got complete clarity of the path to purchase for every customer. So that's what we call the customer journey mapping. That is number one. Now the next interesting things comes in the analytics space. First of all, understanding is itself difficult. Who is the customer? When is he clicking? Where is he clicking? What's his interesting or unique path to purchase? Understanding is one thing. The next level of that is that how you can make that path to purchase very exciting, very personalized, so that the time to purchase gets reduced. So that's something. A lot of modeling techniques come there. Maybe in the next class, I am going to discuss one of the technique called the Markov chain, and we take it to the next Markov chain. Just to give you a kind of quick background of what that is. So when I'm saying I have watched say a TV ad, then a couple of days I start separating the website. So this is actually from state A to state B I am migrating, and from in the mathematical language. And say after a couple of days, an ad popped up from social media. So from state B to state C I'm migrating, and Markov chain is actually predicting the probability from moving from one state to another state. So that's where we use the Markov models. And on the top of that, we simulate a lot. And then we come out with the Markov chain Monte Carlo or Monte Carlo Markov chain MCMC models, what we call it in our day-to-day life. So we apply those models to figure out the probability of the going to the next stage. And on the top of that, we apply another modeling technique. You can take a note of these things, what I'm saying, because those things, MCMs, all those things are not mentioned in the slide, but very critical for you if you want to pursue a career in analytics. The other thing is that sequential pattern analysis or sequential pattern mining. So two things go hand in hand. So not only about figuring out the probability of going to the next stage, but also we figured out the difference of time from moving from stage A to stage B. And so when not only what is the probability of moving to stage D from stage C, but also when the customer is going to move to stage D, how I can reduce the time. Is there a kind of promotional message required in the meantime? Uh, so all those things become a part of your modeling technique. So
So
whatever,
Tuhin,
yeah, please.
so Tuhin, I wanted to ask, let's say, for example,
Yeah.
I am on a OTT channel. Let's say I'm on a Netflix today,
Correct.
and I want usually if I go on a Netflix, then or any of these channels, I find that
Yeah.
there is a certain search suggestion that they give me, which is based on
Correct.
my last searches and all, right?
Correct.
So, for example, let's say today I am in a mood to watch a comedy rather than watching anything serious because it's been
Correct.
a hectic day for me.
Correct.
So, based on my search, obviously all these, Markov chain and all this can, basically work. But say, for example, if I'm going back and, there is a mindset change which is there. And obviously I'm looking at a different genre of movies today, which is not
Correct.
based on the search that I've done.
Correct.
So is there a way to kind of reduce that?
Integrate this one with the product selling. Correct. That's the
Yeah.
question.
Yeah.
Yeah. Absolutely. Absolutely. And that's precisely what we call technically the contextual marketing. So there is a way. It all depends on. Suppose you are selling the product with which all channels you are integrating towards. Are you taking your data from Netflix or any of the OTT channels, or what all sources of data that is feeding into your engine? So I assume if I assume that the data gets feed to your modeling technique, to your modeling algorithm, then it's absolutely possible, and that's what it happens. That yeah, it takes into account that what's the state of the mind of the customer today, what's the customer day to day, how good it is, how bad it is. It tries to figure that out, and uh, accordingly, the entire not only about showing the advertisements, the entire ecosystem again around the product works to make the sales happen. A few years back, maybe around 5-6 years back, a very interesting. I'm sure many of you have watched that. A very interesting video surfaced out that a person whose wife has gone out for a night, and the person is all alone in the home, and that person is trying to want to have a kind of pizza, ordering a pizza, and then the unique experiences turn up like that. The moment the person gets angry, and then the anger management company gives the call. So in that way, there are two things to it. Number one is that, as Professor rightly pointed out, that it's all integrated. It's all integrated, and all the data, not all in reality, but most of the things in reality gets captured. So that's one aspect to it. The other aspect to it is that the privacy of any individual who is online today is severely been compromised, unfortunately. Privacy is a kind of myth unless you are using VPN or any of the proxy servers. So that's thing. Yeah, Professor, to cut the long story short, yeah, it gets captured, and that's what we call contextual marketing. Context is the king. That's what we say.
Sorry to disturb.
Yeah.
So what kind of input variables are we going to use in the Markov chain or sequential planning?
Let me give you an answer two ways. Number one is that what are the obvious variables and what are the other variables that we can. Obvious variables are when you click, view, and impression. These are the three things. These are the three obvious things. Which goes? What have you clicked? What have you viewed? What are your impression? These are the obvious variables. On the top of that, what we collect is the time difference between the different clicks. That's another variable. Now, these are the kind of obvious things. Now, the not so obvious, which is very fast turning to obvious, are hundreds of variables. Now, what are those variables? From which device you clicked? What is the model of your device? What's the operating system of your device? If it is Android or iOS, then what is your network? What is the location? And then lot of variables that we coin out of it. So say location into iOS, location into operating system, for instance. So if I can find out that in some localities, say for instance, South Delhi or South Bombay, most of the folks are turning up or looking at from their iOS device, then my services or the offerings would be very different from another locality which comes with a kind of different network and different devices and different operating system. So actually hundreds of such not so obvious variables also go to the model, and that makes the model extremely robust. Have I answered your question?
Yes, sir. Yes. Thank you.
So yeah, so I'm not reading out every sentence by sentence, but
Sir,
Yeah.
just one more thing. So
Yeah.
this particular model can also be used if suppose I want to upsell my customer or probably downsell some of them, like basis the probability of identifying in which state they are going to be. So
well, there is a subtle difference between two things I shall mention here. One is the Bayesian network, another is the Markov model. By any chance, are you exposed with these terms, or it's all Hebrew and Greek to you?
So I heard of Markov chain.
Bayesian network, do you know by any chance?
Yes, sir.
Perfect. So what is the fundamental difference between Markov model and Bayesian network? The fundamental difference of Markov model and Bayesian network is that in Markov model, your next step is dependent only on the previous step. Say that's what I mentioned that in the example that I gave to you. But whereas the Bayesian network is that your steps are dependent on the 50 others, all the previous steps. That it's kind of complete network, a complete chain reaction. So in the cross-selling, upselling models that you mentioned, we primarily work on the Bayesian network because why? The reason is that you have actually purchased the product or you are going to purchase a product. So we are taking your entire customer experience into consideration, the experience that you have had previously, and then what are your anticipations, what you are going to have. So we plot all of them, and then we kind of match that yes, this is the right product that should be offered at this point of time to make the upsell or to make the cross sell happen. So yeah, they are close, but we use more of Bayesian networks in such scenarios than a Markov model.
Got it, sir. Got it. Thank you.
Perfect. So yeah, determine the best assortment mix based on the available shelf space and financial objective. I discussed in the last class that how space become a constraint, and then how incrementality decides that what all stuff should be there on the shelf, and optimize merchandise decisions to improve the customer experience. At the end of the day, what really matters is the customer experience. So do a lot of experiments. I'm sure you have studied the different experimental designs, and this is the retail store is the right place to actually operationalize all your experimental designs that you have studied, maybe in your research methodology subjects or business research methods. So yeah, like a factorial design, multifactorial design, like different types of colors. Let's say color is a variable. Now say red, blue, green at the different levels of a color, and then the what else? Maybe the store design is another variable, and within the store design, there are different types of store designs. So 3 types of store design and 3 types of colors. So a 3 into 3 factorial design you can create, and then the sales is the dependent variable, obviously, and you can see that which particular combination is generating the highest sales. Am I clear with what I'm saying? I'm just trying to correlate with what you have already studied.
Yes.
Perfect. So number 2 is the merchandise location planning, a very, very important part. That's exactly what I mentioned is possible through a kind of experimental design. So that is both happens within in-store and where the store will be located. Again, not reading it what is mentioned here, but let me tell you, as far as this trade area analysis is concerned, nowadays what we do is something very interesting. Where the world is heading towards is actually deciphering or decoding the satellite images. Now, what happens is the satellite images are very good very good predictor, very good describer of what is the population, what are the number of what at what point of time the people go out from their home to the office, at what time do they return, whether they are going again out after they return to their home. So, and if they are going out, where are they walking towards or heading towards? So all this information on a real-time basis you can get through satellite images. Again, lot of privacy concerns, a lot of checkpoints are there, but keeping all those things aside, uh, to do a trade area analysis, because this kind of behaviors, this kind of behavior that I just mentioned, it may sound very simple, but that would vary significantly from one locality to another locality. Because you are all from Delhi, you are currently residing in Delhi. Even within Delhi, you will find that so many pockets are there, and this behavior will change. Even within a same pocket, say South Delhi, if I consider it as a pocket, uh, within South Delhi, there are several pockets which are very different from one another. So to understand that thing in the real time, the best thing is the satellite images. That's where the retailers are heading towards. Uh, Again, this word is very important, which I shall continuously harp in this slide. Automate. Uh, it doesn't happen nowadays that a project has come, do a demand forecasting for 3 months, 6 months. Some 10-member team are working on a project, and then after 6 months, they're delivering a report of either segmentation or demand forecasting whatsoever. This doesn't happen in this way. That used to happen some 10 years back, but nowadays all automated. A platform is being created, and then data comes in, gets processed, and the output gets generated on a real-time basis. That's the power of automation. That's the power of giving the real-time prediction. And that happens by location, by the store, and that it is all integrated. Again, another word I shall continuously keep on emphasizing is about the integrated. So this entire assortment management, inventory management, the pricing, all these things are integrated with this automated for to predict the sales. Any question?
No.
Okay. Now I shall come to a very important part, is the size or pack optimization. Again, generally we tend to stop by doing the demand forecasting, but it's very important to, as I mentioned in the beginning, that many a times it happens that the sales is lost because the right size is not been found in the store. So the forecasting engine should be such powerful, should be such robust that it would figure out from the historical sales, the true size demand. It will figure out that exactly at what point of time, at what point of store, what is the exact demand for each of the sizes. And then that has to be drilled down to the store or the size level, and then recommend the pack configurations to meet the supply chain constraint and distribution cost. Again, a very important part, because this all would be a kind of constraint to your model. What does that mean? Suppose you found that a particular size would be in demand, but if you found that the kind of revenue that you are going to accrue by selling that size is lower than the distribution cost or the supply chain cost to bring that product to the store, then that doesn't make sense, right? That is something, no-brainer, I know. But important part is that has to be modeled. Important part is that it has to be modeled, because it is very easy if I'm talking about one particular product or one particular SKU, one particular size, but literally you worked with almost a million or a few millions of such SKUs in any store, any reasonably big store or large store. So it becomes humanly impossible to have all those things in mind. So your model should be smart enough, should be robust enough to consider that. Am I making sense? Is it clear?
Yes.
Yes.
Perfect. Now, what are the different functionalities in the size of pack optimization? I shall show you a few screenshots also in the subsequent slides from the software that we use. So that generate the demand-based size profiles, right? So figure out that what are the market-leading loss sales, what sales we have lost because we don't have that size and readily available, create the event-specific scenarios, and automatically detect any active size ranges, and then what are the kind of outliers, what is the possibility of selling those outliers, and build profiles at multiple levels of the hierarchy. Build and use the attribute specific profiles, group products by hierarchy, tag the profiles, recommend the pack portfolios, which of course vary packs by size ratio and overall volume, enforce the constraints on pack usage variation. So in that way, think of all the possible variables, and then that's the key. Think of all the variables and put them into your model. Design multi-delivery strategies, a very important part. Note that all sizes have to be delivered with the same strategy, with the same supply chain, same channel. So think about what are the different channels you can employ so that your cost to bring the product to the store, right size to the store, gets reduced. And this is a very important part. Conduct the what if analysis. Yeah. Even you can do it in Excel, by the way. What if analysis is possible even in Excel. I'm not saying encouraging you to do it to Excel, but I want to say is that get yourself acquainted with the modus operandi, not the tactical way, but for strategic perspective. What is it? When it is being used? What are the problems we can solve through what if analysis? It's a very important thing. It may sound very simple. It is based on business rules in many of the cases, but very handy in many of the scenarios. In fact, two things which cross my mind at this stage, which you must be acquainted with and you must practice, not only acquainted with, is one is the sensitivity analysis, another is the scenario analysis. These two things you must practice, and not only for the retail, these things we have done in even in financial analytics, which is something uh, very different from so-called or traditional retail analytics. But when we do a kind of a risk analysis in finance, what is the earnings at risk, we do a lot of scenario analysis, lot of sensitivity analysis, and that's very handy even in retail. So get yourself acquainted with these two modeling techniques which go hand in hand. And you can start with simple Excel, not that you have to go straight away to Python or R Scala.
Sir,
Yeah.
Just a small question. When
Please,
you're
please.
saying size, do you mean the dimension of that product, or you're talking about like kg, liter? That's what you're
Both,
talking.
both. So when you are seeing the dimension, is the pack optimization or pack size, and it can be the different sizes as well. Like in an apparel, there are different sizes, right? So ultimately, it all boils down to what we call technically the SKUs. It all boils down to SKUs, and every size is a unique SKU. We give a particular number to that SKU, and it's very important to figure out what is the demand of every SKU in a particular store, in a particular location, on a particular day.
So essentially, when you're optimizing it for one complete product line, right? Because
Actually, all the product lines, all the SKUs of every product line on any store.
so like I just didn't understand one thing.
Tell
How
me.
kg, liter, or let's say even if you have like cigarettes. So cigarettes,
Correct.
it's done in sticks. So
Correct.
how do we compile all these three different products all together? And because they have different ways of getting sized. Like one is in kg, one is in liter, and other would be in sticks. So how do
See,
we
at the
optimize?
end of the day, every say there are three pack sizes. One is a 50 gram, 100 gram, 150 gram. Okay, these are three pack sizes. Or every pack size comes with a different variant. Every variant comes with a different flavor. Now, these are the different SKUs. Now, the point is that is it possible to predict every SKU to the minutest granularity? That's the whole point. So if you are talking in terms of cigarette, uh, suppose a brand of cigarette may come at different flavors. A store should ideally, who is selling cigarettes, should ideally be in a position to predict what is the demand of the different flavors and the different pack sizes on any given day at a particular store at a particular locality.
Okay, sir.
So I think what Rajiv is, correct me if I'm wrong, Rajiv. So I think what Rajiv is trying to understand, Tuhin, is that when you have products where there is a liter grammage, grammage could be in a liter. If it is a
Right.
physical product, it could be in terms of a gram,
Mhm.
right? So
Mhm.
also that there is a physical size of the product,
Mhm.
So how do I actually go back and bring in that granular detail in a product which is, say, where we are talking about liter, and when we're talking about, say, a gram
Gram.
actually.
Correct. Now, at the end of the day, there are different SKUs, right?
Hmm.
Say, for example, milk, if I take, milk can be sold in powder, milk powder, and milk can also be sold as a liquid, gram and liter. But at the end of the day, there are different SKUs. Every SKU is a different SKU number. So I can have a very clear idea that from my POS point of sales terminal, I can have a very clear idea that how many grams gets sold, and that grams also in the different pack sizes, 50 grams, 100 grams, 200 grams, 250 grams, 500 grams, 1 kg. And similarly, the different kinds of forms of liters, like 500 ml or 1 liter. Is that what you are trying to say?
Yes, sir. Yes, got it.
Maybe when you are showing some outputs, if you can, illustrate that in your outputs, it would be a good idea.
But do you think there is a gap between what you were saying and my understanding?
I think
If yes,
we have understood. Rajiv, you want to add something here?
No, sir. I got it.
So maybe once we see some outputs, we would get a little more clarity. We have understood what you're saying.
okay, sure.
Because what I was just trying to understand is because when we are modeling it, maybe the model doesn't understand that whether it's a kg, whether it's a
No,
liter.
model doesn't understand. Don't say model doesn't understand. Don't assume that. Model
Okay,
does understand. Model has to understand, not only does understand, model has to understand. Otherwise, it cannot model.
got it.
Otherwise, what will happen? That model will have a kind of mixed effect. What we technically say. Mixed effect means that I'm combining mangoes with oranges in
Yes,
the name of fruit. That is not
right.
possible. Then the entire modeling will have a lot of errors. The entire accuracy will be out of the window. So model does understand how to make the model understand. Model can only understand by a simple number called SKU number, stock keeping unit number. So I don't know if I can show you or if it's visible here. There are different types of shoes, right? Yeah, I think I have mentioned here somewhere because the screen size is really bad. Uh, yeah, so for example, the silhouette, feet, heel height, fabrication, color family. These are the different product attributes, right? Now, all these product attributes are being taken separately in the model. Similarly, suppose I was doing it for a leading pizza chain, then there are different flavors of pizza, and then every flavor is a different SKU. We cannot say that total pizza sales would be this much in this store in this day. Meaningless, absurd. That cannot be. That doesn't mean anything. What is the exact sales of every flavor, every stock keeping unit, to be more precise? The moment you are bringing these 3 letters into your model SKU, model knows it very well, very clearly, without any doubt.
Sure, sir. Okay.
Okay, so that's again a very important question. I understood from where you were coming, and take it from me and remember it throughout your life is that always make your models as specific and as precise as possible. If you are trying to, the more you will combine 2 things, 5 things. Say recently I was doing a modeling technique for a model development for a leading laptop stores, laptop chain across the globe, and they sell, of course, they sell different types of laptops, different types of tabs, and other devices as well. Now, if I just take the total sales, model can never, an effect of the different advertisements, model can never give me a very good accuracy. If I just take also laptop sales and only the laptop advertisements, still that is not a good model. You have to always break it down. There are different segments of laptop. Some are gaming laptops, some are used by the professionals, some are meant for the students. So there are different chains within a laptop itself. So you have to actually break it down to that level. Always break it down. That's the kind of, mantra, I would say, of doing any modeling technique. Always break it down. Don't try to compile. The moment you will try to combine, then you are actually mixing 2 or 3 effects, and then the model can never perform well. Even if the model performs well, suppose by chance you get a kind of high accuracy, but then you cannot put it into effect for the simple reason that where do you spend the maximum money for which particular laptop, because it's a mixed, or what you are going to have in your store, which particular pack size, 500 gram or 1 kg. So always break it down at a SKU level.
Sure, sir. Thank you.
What you can say is that sometimes it happens. Sometimes it happens is that some SKUs that that sales are so low, it doesn't make any business sense to have the model separately for that SKU. Then we try to combine. That happens. I agree. And that we do with the consent of the retailer. Yes, can we combine this 25-gram sachet and 50-gram sachet together while doing the modeling technique? Because that consumer, what determines this combining part? The consumer behavior. We find the consumer behavior is exactly same. The way they purchase, the way they approach this 25-gram product and the 50-gram product are very similar. Then it makes sense. But otherwise, the philosophy should be to segregate. And if the demand be, if there is a requirement, then only you try to combine. Making sense?
Yes.
Sir, yes.
Perfect. Okay, so yeah, exactly that's what I was mentioning. So we create the size precision scorecard. So that provides how accurately each location matches the selected combination of pack configuration or bulk to the targeted units by size. So exactly how much of every pack size is required by which population, at what store, on what day we do it. So the pizza example that I was giving to you. So when we are doing this kind of modern technique, always remember that what I was saying, that bring as many external variables as possible into your model, and that helps a lot. Now, we found that pizza stores that are located in the multiplexes are somehow dependent. The sales is somehow dependent whether the movie is hit or not. So even have those IMDb, Rotten Tomatoes scores into our models to figure out what is the rating of the movie, and the model become robust. We also figured out that whether the pizza store is located at a street, and what is the traffic that flows from that street at what point of time. So what is the optimum traffic we can expect that would maximize the sales. So lot of such variables which the company or which the organization for which you are working might not give to you directly, but you have to think very creatively and you have to bring those data to your model. So yeah, the same thing is the kind of the dashboard represents that these are size demand profile difference by location, how with the location the size demand changes. That's been shown by a kind of dashboard. This is the size demand by product and attribution. As I have shown here, there are different, depending on the attributes, depending on the sizes within the attributes, you have to actually create a kind of dashboard through the different demand that has happened at past and what is the different demand that you are forecasting. And the very important piece is the price optimization. Again, that's a separate, I would say, genre to discuss, a separate subject to ponder over, reflect on is price analytics. But to keep it simple, we cannot in today's world, we cannot have a one price to one product every day. That is something passive. I shouldn't use the word stupid, but that's something kind of passive. For the obvious reason, because that doesn't generate either the maximum sales or the maximum revenue. That doesn't help. So how you can create a kind of dynamic pricing? So Walmart did it long back, EDLP, everyday low pricing. So in that way, every I'm not saying that you have to follow EDLP, but every store might have their own pricing policies. But point is that the pricing policy should be dynamic enough to somehow be related with the environment, external environment. External environment can be the computer pricing, can be the 500 variables which are happening in the environment. So, and even on the product life cycle, not only the external part, but also over the product life cycle. So the same product life cycle, keeping all the external environment into constant, keeping all those variables constant. Even in the same product life cycle, the pricing would change. Typically, we use simulation techniques, and that's a separate, as I mentioned, separate genre or separate ballgame altogether. To use the different kind of simulation techniques to arrive at the right price point, that what would generate the maximum sales and maximum revenue at any point of time or any point of store at a particular day, particular locality. So that's the price optimization part. So the beauty is that these slides are all written in English, but every sentence has some analytics models behind it, which I have not mentioned here, and that's what I'm supposed to discuss it with you. So what are the price merchandise planning and price optimization benefits? First of all, yes, improve the key performance indicators. That's a very important thing. Enable the better assortment planning, localize and drive profitability, boost in-stock service levels, increase profit margins. And last part is very important, is that it implement analytics. Now, this may sound weird, but it has got huge importance in the sense that many of the companies, many of the data scientists, they do the mathematical models as a kind of intellectual exercise, kind of boy it out of doing or developing a model. It is giving me 94% accuracy. Wow. But that really doesn't help as long as it doesn't translate to the business user with actionable insights. So whenever you are doing any kind of modeling, whatever maybe the name, whether it is, as I gave a couple of examples in the beginning of the class, like Bayesian network or Markov model. Honestly, a retailer doesn't care. Honestly, no organizations don't care what modeling technique you use at the back end. What really matters for them is that whether they are getting the actionable insights or not. So try to think how you can create a kind of front-end dashboard, front-end visualization technique. I mentioned like Tableau or Microsoft Power BI. It can be click view as well in my previous class. So get yourself handy with the visualization tools and techniques. That's very powerful. That actually helps in translating the raw models to a kind of actionable insights through graph, charts, scorecards, which the business guys can interpret, relate, and take actions out of it. So, okay, so first part is over. Any question before I move to the second part, customer insight?
No, I think.
Okay, perfect. So customer insight, as I gave a kind of, in the introduction, I gave you some highlight that what it is about, know exactly what your customers want, and make sure they get it. It's very critical. Both the things are very critical. I could have made a one sentence out of it, but then I broke it. Yeah. Now, knowing is one thing, but knowing does not necessarily mean that you can give the right product or the right service at the right point of time. So making sure that they get it, that's very important. And these are all, when we possible, say, make sure they get it. What I really meant when I wrote these words, what really crossed my mind is the replenishment analytics. So, which I have given you some kind of hint in my last class that, yeah, inventory optimization, replenishment analytics, they all know somehow they may be a part of, they may sound like a part of supply and demand planning, but unless these things work well, you cannot make sure that they get it. You may know your customers through a lot of segmentation, micro segmentation, micro profiling, whatever, but you cannot make sure that they get it unless these guys work pretty hard. So comprehensive view of customers and business, again, a very important part. Easily access your data, no matter where it's from or where it lives. The greatest challenge even in 2021, you will face when you will move to or speak with any business guys to do the models. If they're Indian guys, Desi guys, no matter how big they are, I don't want to name the big corporations, but no matter how big they are, they will tell you one thing: why data hi to nahi hai. That is the simple answer. इसका मतलब ये नहीं है. It doesn't mean that the data are really not there. The data are there. but they are in silos, they are in different departments. There is not a kind of one data lake. There is not one version of the truth. That's what we mentioned. There are multiple versions of the reality and residing at multiple localities. So that's why the first thing, what we do, and of course, don't think that there is a problem for this country only. That is true for any corner of the globe, even if it is the kind of US corporation, any MNCs, multinational corporations, wherever we go, that having the right data at the right place is the biggest problem. Analytics will come at a much later stage, honestly. That's why, after I tasted this water, after I sensed this form of reality, I was discussing with Professor Dasgupta in the beginning of my previous class. I opened a vertical of my business, of my organization, is data engineering. That is, by have the first thing is to have the right data at the right place. Then only analytics will come. Analytics will come at a much later stage. So the data engineering, data governance, that's the first thing. So I guess to have the comprehensive view of customers and business, the first thing you require is that you cannot just rely on marketing department data or the different forms and data. These are different, residing at different silos and pockets. So you have to combine all the data, create a single version of the truth. That's the first thing. From there comes the second part, is the integrating the multiple and online offline data sources, including IoT, which I'm going to discuss in my next class, where tomorrow I'm going to discuss much of technology, retail technology that's associated with analytics. So yeah, IoT, customer merchandise, location data. So that's very important. Try to integrate, try to ask questions. So since this is a part of analytics, let me tell you how to approach client. Don't jump into modeling from the very first check. Never commit that mistake. First couple of weeks should be spent on two things. One is the business understanding. Number two is data understanding. Business understanding is very critical for that purpose. Conduct as many interviews as possible. Say, for instance, at one point of time, almost 5 years back, yeah, SpiceJet was my client, and then I didn't know anything about aviation, honestly. Uh, I am not a kind of aviation engineer. I don't know how the flights go. But then I was supposed to develop a fuel analytics model for them. Uh, why? For the simple reason that if you have got the slightest clue about this aviation industry, fuel drives more than 50% of the cost of any airlines. So that's why fuel is very important. Now, I didn't know how the fuel, how this entire engine works, all those things. But then what was at my disposal is that all the pilots, all the ground staffs, all the aircraft maintenance engineers were at my disposal. So I spent first couple of weeks of the project at that Gurgaon office, Gurgaon SpiceJet office, and then interacted with many pilots, understand how it works, when to give the landing gear, at what point of time you can give landing gear to save the maximum fuel, when you are taxiing at the runway, whether you are going to operate on a battery or you are going to use the fuel, how much extra fuel you should carry in case of emergency. Lot of variables are there from the flying perspective, from the ground maintenance perspective. The point here is that don't now I shouldn't, and one shouldn't, even if you have got some clue about the business, don't jump into the modeling technique from the very first day. Understand the business, speak with multiple people, uh, organize as many interviews as possible in the first couple of weeks, 2 weeks, 3 weeks, even if it requires 1 month, let it have, because that's the kind of, that will set the direction of your model. Otherwise, if the direction is not set right, you will end up in a kind of different destination altogether. And at the end of all your modeling technique, when you are going to present your report, the CEO will say that, hey man, you don't have any clue about your business. It may be a good model for you from your perspective, but that is not useful to us. And business is over there. So be very sure you are completely immersed into business. You cannot afford the luxury that I am a data scientist, I am a statistician, I need not know the business. You cannot afford that luxury. That's not a luxury, that's kind of stupidity. Don't be into that kind of, many data scientists do that thing. They consider that they are statistician, they are come out of ISI, and though ISI is not, anyway, let's not comment on that, uh, but point is that be a business guy. That's your business should drive your statistics, not the other way down. Not statistics will drive the business. That's the very, very, very important mantra you should always keep in mind. I hope my perspective is clear, right?
Yeah.
Okay, perfect. Because I'm speaking in a flow, so I must ensure that you're all understanding. Yeah. Okay, so other thing is that the real-time customer interaction optimization is a very important thing. Now, I have not mentioned anywhere about in this slide that what all modeling techniques gets embedded into it and what's required. Now, say for instance, let me give you a simple example. You are speaking with, not you means you, an individual is speaking with the call center guy. Not necessarily call center means always selling a personal loan or so. It can be a kind of maintenance, it can be for several reasons. But we just leave the entire customer experience at the mercy of that call center guy who is supposedly be trained, but then also it has been left at the mercy of the judgment at that moment of that guy who is interacting. So just one example here is that intonation mining from the conversation that is taking place. If an intonation mining algorithm being attached to that conversation through the speech mining, of course, and then on the dashboard of the call center guy, it can pretty well be reflected that what is the state of the mind of this customer. Is the customer depressed, angry, happy, frustrated, and accordingly, what is the right word which needs to be used? That can always come up. And of course, in US, it is not still in India, but in US, most of these calls are being done in an automated way, not that human guys. Sometimes I need to even ensure by really asking. I literally asked once that, are you really a kind of some individual or you are a kind of automated robot? So most of these calls are being done by the automated robot. And then all this, it is not only about the natural language generation or natural language processing, but a lot of other speech mining, intonation mining algorithms are embedded to it, attached to it, to make that real-time customer interaction the best to optimize. Am I making sense? Is it clear?
Yeah.
So that makes it, yeah.
You talked about that companies are dealing with the no data, like they are not getting from where they can generate that data. One more aspect of this can be, sir, if real-time data is getting generated, so it would be very humongous in nature.
True.
So from there, how are companies right now they're analyzing that data? Because ultimately, even if you have a huge chunk of data, it would mean nothing to you unless and until analysis is done over it.
Absolutely.
So how are companies doing analysis over a big data, so to say?
That's a very, what should I say? It's a very, very broad question. How would the companies analyzing big data is a very broad question. You have to think of that. What is the objective here? It is not doing an analysis for the sake of doing analysis, right? What is the objective that you are going to accomplish out of analyzing the data? So depending on suppose if you are going to do a kind of segmentation out of the data, you can think of the different clustering solutions. If you are thinking of developing a kind of what else, the sentiment analysis, then you have to think of how you can analyze the words or the qualitative data. If you want to integrate the quantitative data on the top of it, again you have to think of how you can make use of the quantitative data repository that you are having on the top of the textual data. So it's your objective, what kind of analytics tools and techniques you are going to use. That all depends on what objective you are going to accomplish.
So, sir, essentially, I was like not asking from the modeling perspective. I was asking like which particular data points the company should look for in order to do some analysis out of the entire chunk of huge data.
Again, depends on the objective. Again, depending. Suppose for one objective, some data points are important. For the other objective, some other data points are important. So depending on the business objective, the data point gains the relevance.
Okay, sir, got it.
Intervene and respond to that, Tuhin.
Hmm.
So Rajiv, for example, I don't know whether you have been following this. Dark chocolates today are helping in reducing menstrual pain. because dark chocolates have magnesium in that. Okay.
True, true.
So a qualitative survey kind of revealed in a focus group discussion, that this is an attribute which is coming in. So if I now go back and do a little bit of backend, handling here, I could start looking at putting. So I'm a dark chocolate guy, and historically I've been using traditional stores like the modern retail formats and all for pushing my dark chocolate. But suddenly a data like this helps, can help me in pushing dark chocolates in medical stores also. So now once I have, let's say for example, I've taken a decision and I start putting dark chocolates in medical shops also. So maybe, maybe it sounds a little weird, but then, just let's take the example from on the face of it. So now I know that, in a medical store, there is a dark chocolate. So there is a certain amount of data that starts coming in from there also. Now, as you know, when Tuhin was talking about in the earlier slides about SKU and this and that, I could now start breaking it down, because once it's not so random that I just go back and start putting it there, because there are supply chain implications and all. So the question is how much can I optimize, and what are the kind of SKUs, at what cost can I go back and start exploring the medical chain, medical stores, so on and so forth, because the entire context there would be very different from, say, putting it in a model format and all. So there is a qual side to it, there is a quanti side to it, and of course at the end of it, if I have to do a SKU management, how do I handle it, and eventually I think this is the cost that we're talking about. So I don't know whether Rajiv, I could help Tuhin in responding to you.
Yes, sir, I got it.
Let me add a technology side to it, since I'm coming from a technological background. What we do is that whenever most of the companies nowadays have the database. It's not that they don't have database, but what we do is that once a particular project is been created, we curate a kind of data lake out of the database, which has got the all the reasonable, all the really required data points, which helps us in the modeling part. So data lake is one answer to your question, that what particular data points that are required, we have it in the data lake for better managing the data.
Okay, sir.
Okay, let's move. So yeah, the third part is the end-to-end integrated solution. So again, as I mentioned, that it should be integrated. It should talk to the different components. It cannot just remain in silo. So say for instance, if you are doing a kind of demand forecasting, it should talk to inventory optimization, that should talk to replenishment analytics, that should talk to the transportation analytics, that should talk to network planning and distribution centers, that finally talks to the assortment optimization, which should talk to the POS, point of sales terminal. So this should all be integrated and connected. So it's not that I'm developing a model in isolation. That won't help unless that is integrated and that can talk to the entire ecosystem. So it's very important to understand the entire ecosystem to create an ecosystem of models or analytics or AI. So that's where the world is heading towards. It's not only heading to, it's already reached there, that not a kind of single model. It's a kind of entire ecosystem around the business that we are creating. So what is the benefits of customer insights? The first one, as I mentioned, is the connect with your customers in real time, sell more, spend less. So these are obviously the benefits. Now let's move to the third piece of the pillars, is the supply and demand planning. Accurately plan for the customer demand down to the individual store level. So as I mentioned, it should be highly automated, fully integrated. I always emphasize on these two words, automated and integrated. Without that thing, it will not fly. None of the models, even if it is the best of the best models, it won't fly, it won't be acceptable if it is not integrated, if it is not automated, because nobody will ask you to develop a model after every 3 months, after every 6 months. That's not the point. Nobody is interested of such a kind of arrangement with any vendor. So that's if there is no automation, the model cannot fly. And if it is not integrated, again, the model cannot work, because that is in isolation, that won't help in the long run. So always think. Now, why these things are important? Two things. Number one is that what is your technology choice? depending on the existing, it's not that you will approach any company who has got nothing on that table. There should be already different kind of IT related technologies on that table. So you should approach, you should have your language, your platform for that matter, not only the language, but also the entire platform should be such that that can easily be integrated, that can easily talk to the existing ecosystem of your client. That's a very important part. So, and from the very beginning, you should be cognizant about that fact. You shouldn't develop any models if that cannot be integrated. Otherwise, it will take a lot of pain, lot of effort at the end, and you cannot deploy your model. So, I'm not teaching you analytics here. I'm teaching retail analytics. But when you will learn analytics, give special emphasis to the model deployment part. Many of the students I have seen that they get engrossed into the model development part, model testing part, but then they forget that how to deploy the model. They think that it's the kind of engineer's job. Yeah, of course, engineers deploy it as long as you give the right language, right codes to them. So even if you don't do it, but you must be cognizant. Even if you don't do it by yourself, but you must be very well cognizant about the model deployment. But how shall I deploy my model to the client server? That should be the question you must be able to answer from the beginning itself. You should have that vision. Otherwise, you will develop everything, and if you don't know how to deploy that model, sometimes, though it happens rarely, but sometimes it happens that the model is not deployable. So that's a pathetic situation, I would say, for both of you and your client who has already spent a decent amount of money to develop the model. I hope the perspective is clear, right?
Yeah.
Great. So yeah, the small, medium, or large scale forecasting. Maybe in my next class, I shall throw some light on the different forecasting techniques that are being used these days. It's no more that kind of ARIMA time series. They're all, some 20 years back, 30 years back, they were in use. Not that they don't give good results. Yeah, I'm not saying that thing. I'm not demeaning them. But what I want to say here is that a lot of modern techniques based on deep learning has come in today's world. And another important thing you must be cognizant of being a student of analytics is the architecture of the models. It's not only about developing a model. Maybe again in the next class, or not next class, maybe on Monday when I'm going to take you CLTV, I shall give emphasis on the demand forecasting and that architecture part. It's very important that how you can actually tweak the architecture of the models, and then one model can be on the top of the other. One model will give the output of one model will become the input of the next model. In that way, there can be a series of models. Not that every model has to be different. There can be a series of RNN. There can be a series of CNN, which can help you in giving the right output. So think of those ways. What are the how I can actually create a robust architecture of the model? So study the architecture very seriously. And when I say architecture, don't think that I'm talking about architecture within a model. That's one way of that is the first step. Rather, I'm saying about architecture of the entire output or entire ecosystem that you give, in the sense that one is, of course, how the data will come, how we'll process, how we'll store, how we'll what are the kind of cache system. That's the architecture. But the other thing is that within the analytics piece itself, that's the entire IT ecosystem. But within the analytics piece only, how the different models, because nowadays nobody gives just one model. It's a kind of series of models, and one model will talk to another, and then they will give the right output. So how you can create a series of models, how you can create the hybrid models and generate the output. So think from that perspective as well. So a lot of creativity is required, not that I'm sure you know that nowadays the data science analytics is heading towards automation. Again, a very important concept, listen it very carefully. Data science analytics are heading towards automation. So what does that mean? It means that right from the data collection to the data processing, or applying the right modeling technique, which particular modeling technique needs to be applied, to the feature engineering, to the model development, multiple model development, comparing across the models, and then figuring out the right model or the best performing model and deploying that model. This entire thing are being now done in an automated way. Have you heard about a company called Databricks or Data Robot? Data Robot, have you heard? If not, just visit their website today. It's datarobot.com. They are doing this automation from quite some time, from quite a long time. And nowadays, so as I mentioned, that this whatever we used to do at 1.10 years back, what it used to take 3 months to do a project, now this entire project can be done in 3 hours, if not on a real-time basis, through this automation of data science, automation of analytics. Am I clear here? Any question?
No.
Great, great. So one must do homework for you is that study the automation of analytics part by yourself. Study how the data science being automated nowadays. It is not only automating the different other tasks, even the analytics model development, model creation, model deployment, model comparison, entire thing has been automated and can be done in a few minutes, few hours, depending on the complexity. Okay. Now, what I was saying to you is that, yeah, those automations can be done, but this kind of architecture part that I was saying, that if you can really be a kind of, there's a difference between a cook and a chef. A cook can only follow a particular recipe and come out with a kind of output, come out with a kind of dish. Whereas the chef has his or her own signature to a kind of dish that he or she prepares. So that's the kind of there is a kind of difference between a cook and a chef. The same thing is between the data scientists. There is a kind of brand of data scientists. So even if there is automation available, but then also if you can become really creative in developing a unique architecture nobody has thought of, just like creating a unique recipe for your cooking the food, or creating a kind of cocktail, a new mixology, and you come out with a new way of creating a cocktail. Those things are heavily, deeply been respected and appreciated in today's world. So that also you must think of that, knowing the architecture and how I can create my own architecture and develop such solutions that no other automated techniques, automated platforms can give. Making sense to what I'm saying?
Yes.
Okay. So yeah, demand sensing and shaping, like visually analyze demand data, spot patterns, new products, locations, what particular channels should give, what particular channel should be attached or tagged to what particular store, at what particular locality, for what particular product, within the product, what particular pack size. So these things all you have to, these are all your variables. And that's exactly what I mentioned in the what if scenario analysis. If you use A and B, then what is the effect on C and D? So this kind of continuous what if scenario analysis you have to do to come out with the best way. So make yourself handy with these what if analysis, scenario analysis tools. And so that comes immensely useful. And on the top of that, always use simulation. Simulation with the real-time environment. Suppose you know that the demand might vary from say 6 to 10. It can be whatever you need. But if you can simulate within that thing with all the combinations, that would give you a kind of optimum result. So practice those things.
Can you give a practical illustration of the what if scenario analysis?
Yeah, exactly. What I just gave to you, I was doing it just a couple of months back for a bank. It was a kind of course, multinational bank with the headquarters in Singapore. And I was doing the risk analysis for them. Now the thing is that, and to be more precise, there is something called EAR. If you know about those who are from the finance background, they must know there is something called earnings at risk. So every bank has to earn, and that risk is dependent on so many things. So many things. It can be the currency fluctuation. It can be the global environment scenario. A lot of variables are there. The thing is that I have to, and they have to report that what is the risk level, and depending on that, their borrowing is dependent. So their entire bank's functionality depends on this kind of risk assessment analytics. So what are the different kind of given global scenarios? Say, forget about the different. Let me take about one variable, which is called the currency fluctuation or currency prediction. If now, to a large extent, a bank which has got which continuously interacts with multiple countries' currencies, if they cannot predict or forecast the currency fluctuation to a certain level, then they will have a very difficult time because they might take a loan at a wrong time. They will again repay it back at a wrong time, and then the business will suffer. So what if scenario is that what is the first of all, you have to predict the currency fluctuation. That was the first engine we developed. And then once that has been developed correctly, then if I'm just thinking about one variable, there are 50 other variables besides currency, literally more than 50. And suppose if currency fluctuates for this country between this range, then what is the impact on the risk? That is the what if scenario analysis. Am I making sense here?
Yeah.
Great. So yeah, inventory optimization is another thing you must have done in your childhood. All these EOQ models, all those things. And then point is that apply analytics there, apply simulation there, and see how that is integrated and automated. Benefits are pretty clear: improving forecasting accuracy, optimize inventory, and reduce stockouts. The guesswork out of forecasting, no guesswork there. We will have robust architecture, robust modeling technique. Now we will come to the next part, is that COVID-19 threw some very difficult challenge and different challenge for the retailers as well. The first challenge was that certain products demand went very high, certain products demand went very low, and products whose demand went very high, the supply chain was not capable at one point of time. It happened that talking about say, March, April, May, when it just took off, the supply chain was severely been destabilized because of the COVID scenario. The flights were not flying, the ships were not carrying. Of course, the entire shipping industry set a huge setback, and so how to tackle those things? So that's the entire supply chain scenario planning you have to do it. So yes, given the kind of scenario, what are the kind of constraints that have come? Create the consistent synchronized plan for purchasing, inventory, transportation, sales, manufacturing. Run multiple scenarios for demand forecast on different recovery expectations. What is the potential markdown? What kind of promotions that should be applicable here? The existing promotions which were there in the pre-COVID scenario was not helpful because everything changed at that point of time. The consumer, one point of time, consumers started stocking a lot. Whatever made they thought that products might not be available in the store. So whatever the food items, whatever they fail, even if they don't require, they started stocking. That further create a kind of bullwhip effect of very severe crisis in the supply chain. So that end-to-end supply chain scenario planning you have to do, keeping the consumer behavior in mind, supply chain demand sensing. So what happened in the short run is that facing the critical challenge of how to predict and plan for the significant change in consumer demand. So we started doing the very different kind of demand forecasting. All the past sales now at the point of time that past demand, past sales didn't work. So we have to always not that those data we just didn't run, but then on the top of that, lot of other variables. What could be the scenario? What is the scenario, and what could be the scenario at every locality? We predicted that. What is the kind of, because consumer behavior is consumer panic at that point of time, and their behavior was very different. So what is the COVID? How many COVID patients got infected? What is the hospitalization ratio? How many got recovered? What is the customer sentiment in that locality? So all those variables went into the modeling for the demand sensing. And then there is short-term product substitution, like when we understood that yes, certain products which are coming from overseas, we cannot give it to the store even if there is a demand. So what kind of product we could give? The product substitution, and then how we can promote, how we can give the message to the customers. So that's the other part of the short-term product substitution, which lasted for 3 to 4 months. But honestly, most of the retailers had a kind of sleepless nights at that point of time. And basket optimization is something again was very different from the traditional market basket analysis that we used to do earlier. Because at that point of time, the way the consumer purchased, as I mentioned, that getting hurt by the panic or the kind of global scenario, they started purchasing a lot, purchasing in bulk. So we found interesting market basket behavior at that point of time. So
Sorry to
naturally,
intervene here, Tuhin.
yeah, please.
So I wanted to ask that, for example, if you see in the COVID scenario, what happened
Yeah.
was the small retailers emerged as the poster boy. They were the ones
Yeah.
who actually were able to kind of bring in better turnaround time,
True.
quicker replenishments, and
True.
some of the stuff that you're talking about is better basket optimization and all.
True.
So historically, if I see, most of the stuff that we've talked about in terms of retail analytics would work better in a, in a organized kind of a retail format where the data is there and we are
True.
able to kind of go back and bring in a little bit of control in the whole thing.
Hmm.
But say in a post-COVID world where the small retailers are bringing in new kind of stories, and new kind of stuff which is emerging from there. So how do I kind of capture that into my, say, a thing like basket optimization, or probably in the previous slide when you talked about some of the other stuff. So is
Yeah.
there a kind of dichotomy there, or it's still a work in progress, or what is it?
It is actually not dichotomy, but a work in progress. That's the best way I can put it. And to be honest, all these small retailers, they have a very good idea about the ground reality, and their mental mathematics. They also see mathematics is nothing but a kind of a representation of the reality, representation of abstract reality. So even if they don't come out with the algorithm or a kind of any equation, but their mental mathematics is super. They know it very well. Okay, Mr. X is going to come on this day of the week, and he or she is going to purchase these 5 stuffs, 10 stuff. They know it very well. No, formal equation is required for that. So that's how they own the heart, because they know the ground reality so very well. Um, and 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 uh, and they can also serve, as you rightly mentioned, that they have 5 guys under their belt, and those guys can easily serve. They know every locality, every house, every apartment with a house, and they can pretty easily go and then serve whenever it is required. So that way, of course, it's a work in progress in the sense, because they are all heading towards the same goal. Whether it is a kind of formal way of accepting the mathematical modeling, or a kind of not so formal equation, but a kind of mental mathematics going on at the background, which helps them to give or reach the right products at the right customer at the right point of time.
So for a market like India, where the bulk of the trade is still unorganized, and
True.
we still rely very heavily on the retailer's instinct,
True.
right? That mental maths that you talked about.
Correct.
That ultimately, it's all about the dhanda that the guy is doing
True.
at the galla.
True.
So suddenly all of this stuff that we are having in terms of the conversation becomes a little redundant, because of the fact that we are all going back to that galla and to see how, because the greater part of India relies very heavily on this kind of a trade. So how do you see this whole scenario building up in the next couple of years, and especially where this kind of a sudden emergency of the pandemic coming in, so on and so forth?
Well. Here I won't say that it has not been redundant. So I'm sure you have studied, or we all have studied very minutely, the growth of modern trade. So uh, 2007 or 2006, at that point of time, when retail became a modern trade, became kind of buzzword. At that time, we have only 4% of modern trade, but still it became a buzzword. Everywhere the malls started coming up, and people started experiencing the departmental store. Big Bazaar came up. All those things happened at that time. Even the education industry started offering the retail analytics courses. All those things started. Now, at that time also, 96% was unorganized. Remember. Now, what happens is that slowly, it's a kind of evolution. It's an evolution. Even if this kind of unorganized, so-called unorganized, they have also started becoming organized. May not necessarily in the form of mall, may not necessarily in the form of a departmental store, but in the form of the supply chain. Now, think of a guy, think of a small shop who is taking the delivery of, say, 50 ring soaps. I'm just giving an example, or 50 Ariel packets. Uh, do you think a truck is coming just for that guy? Not really, right? So think of that, that truck that is coming to a distribution center, and from the distribution center, it is all getting transported to all the small retailers in the even if it is in bulk size, but still in very small quantities in comparison to departmental store. So this entire process get evolved, get operationalized in a mathematically in a much evolved way, what it used to happen some 20 years back. So that way, even if or apparently they may look like unorganized, they are small stores, kirana stores, but they are all a part of ecosystem. They're all a part of ecosystem because they are stocking those products, and the entire supply chain that is catering to those stores are being by these mathematical models. So these models are not getting redundant, but yeah, what I can say is that but after the pandemic or during the pandemic, we keep tweaking these models given the situation.
Got it. Thanks.
My pleasure. So yeah, this is the fifth point, which I always keep emphasizing is the operationalizing analytics. Always think from whether you are doing it kind of SaaS or any open source or the third-party vendors. Always try to think of how I can operationalize my analytics. Without that thing, or implementing my analytics, without that thing, your models is just a kind of intellectual exercise, or yeah, mathematical exercise, intellectual joy that has got not much meaning for the business. Now, the last piece in the last 5 minutes I'm going to cover are the how the analytic adoption across the retail sectors. So how the grocers and pharmacies use analytics, they reduce the churn. Again, I'm going to use or discuss this thing when I'm going to discuss CLTV on my Monday, how to reduce the churn and how CLTV is an important part to it. Increase the customer profitability, run the demand-driven supply chain, where they in the efficient inventory policies, optimize the stock levels, keep customer service levels high. Uh, Very important for the pharmacies that during the COVID scenarios, certain drugs, you must be all knowing, the demand went very high at different points of time. So the pharmaceutical stores always tested the water that what particular products, what particular, and not only they reacted after the demand went high, but also they anticipated pretty well in advance. And please remember, they cannot just rely on the past data for that. And there comes the endemic analytics is the kind of altogether a kind of different genre altogether during a kind of pandemic, different kind of this kind of crisis. What kind of analytics will play? What kind of survival analysis will take place? And what kind of medicines? What kind of services? The demand of those medicine services will go up. That also we figure it out pretty well in advance, and then ensure that that reaches at the right store, so that the consumers get it when they require it. Hardline or the DIY retailers, hardline and softline, you must be knowing the difference, right? In the retail sense, the hardlines are literally hard and do it yourself, like all the home stores, literally hardwares, all the office staffs. They reduce the inventory and increase sales by better managing product categories. Hundreds and thousands, you go to the Home Depot in India or across the globe for that matter. Their way of doing or adapting the analytics is, or their models are very different from the groceries or pharmaceuticals for that matter. So again, a very important part what I wanted to emphasize here, these apparel softliners or these e-commerce specialty retail stores. Don't think that retail analytics means a kind of one thing. Depending on the type of retailer, that's why understanding business is very different, very important. Depending on the type of retailer also, because their turnaround time, the shelf life of the products, everything varies significantly from sector to sector within retail. So it's very important that your model should capture the reality, because the variables that you will incorporate for an apparel store will be very different from the variables that you are going to use for the grocery or pharmaceutical. So please ensure that you really understand the business, and then your model should reflect the realities, the variables that are the most critical for the retail sector for whom you are using the model. Last but not the least is the last slide, the last minute, is that the key enablers is about. I always emphasize on that you means be you are a kind of vendor or a client, irrespective of that, whether you give the business or a kind of maintaining the data of a retail store. You should have a strong data strategy. That's very important, which includes your data lake strategy, data swamp strategy if required, database at the back end, then how the data will flow, the data governance, how the data will be consumed, what will be the output. This data strategy is very, very important. Analytical merchandising goes without saying. I'm saying on the very first class how the AO assortment optimization will take place. Intelligent marketing is very important, right? Whom to market at what point of time with what product, so that the purchase motivation gets the highest. So that's the intelligent marketing part. And this is the very important part, is that an open analytic ecosystem. Your model, which we call technical, is the scalable. Your model should be scalable. Everything should be scalable. It should be open. It can talk to all the components. It can be integrated to all the entire ecosystem. It should be such open. Otherwise, even if the model is great, it would be of no use. That's the point. Okay, we are just in time, I would say. Any questions before I call
I think,
it?
Tuhin, one thing is that once you come back tomorrow, if you can discuss about some of the technologies which are involved in doing some of the stuff that we have discussed today.
Tomorrow, I think 1.5 hours, I shall discuss on the technology only, technology for analytics.
Great. On retail analytics.
On retail analytics, to be more precise.
Yeah. Any questions, class?
So one question about mention about forecasting and the waterfall. So with a lot of variables in the global market, how accurate can these simulations be?
Nothing is accurate, but unless you see, it is about accurate means if you say 100%, nothing is 100%. It is all about, say, let me give an example. I developed a model for a kind of, say, I gave the same example. Let me give you this example, yogurt. Right, that was a kind of UK client for which I developed the model. That model was giving me 80% accuracy. Now that definitely not 100%, so there is 20% error still. Now I added the weather variables on the top of that. The model actually improved 5%. It moved to 85%. It was a huge gain. On the top of that, I included the holiday variables. What are the days of the when I say weather variables, don't think that every day's weather, temperature, like that. Nothing like that. From there, we calculated different other variables, like the hottest day in the coldest months, or the coldest day in the hot months. So in that way, a lot of feature engineering we do. We come out with the new variables, and then we smartly incorporate those variables. It's very important. Feature engineering is very important. Don't just include or incorporate the raw variables. You have to do a lot of feature engineering before you include the variables. And then, as I mentioned, the holiday. We included the different kind of holidays. It is a kind of summer holidays, and at what point of, then once you included the holidays into the model, it moved to another 4%. So finally, a 80% model moved to 89% after incorporating these two things only. We further included other things also. Finally, the model went up pretty well, around 95% or so. But the point is that your question was that how accurate. It is not about, it is not about nobody can reach 100% accurate. But the point is that every inclusion, every incorporation of this kind of, every smart incorporation makes your model take a step towards the accuracy, towards the 100% holy grail, I would say.
Thank you, sir.
Thank you.
So
Thank you, Tuhin.
Any specific technique in feature engineering which you are using right now?
It is not about specific. That is what feature engineering is all about. That is no specific thing. You have to smartly understand the business and come out with the new variable. Say, for example, for the yogurt. So if I come out about what is the kind of hottest day in the hot month, or the hottest day in the cold month, coldest in the hot month. Now, this is not something nowhere written. But then you have to smartly figure out that what could be the variable. So don't look at the data first, look at the business first, because the business will follow the data will follow the business, not the other way around. So think about the business and think about that what could be a very important thing for this business, and then try to create that thing, try to create a new variable out of your given data for the business. So that's feature engineering. Mix some 3-4 variables, one multiplied by the other, divided by the other, like that, and create a new variable and use those variables. Don't use the raw data. Feature engineering is the key of a good model. Otherwise, no matter what modeling technique you use, if you don't create the right variables and use the raw data, life becomes difficult.
Thank you, sir.
Welcome. Welcome.
Thank you, Tuhin.
My pleasure. Have a wonderful day. Bye-bye.